Okay, so in this problem, we have three unknown forces that we need to solve for. We have our force from the beam from D to C, and then we have the force from the pin A in the X and in the Y. Because it's a pin, so it acts in both the X and the Y. We have a known force over here, F1, which is 4 kilonewtons. We know that distance is 3 meters, and that at the halfway point where FDC is 1.5 meters. So using that, we can do our components for DC. So we can solve for the components of force DC using the triangle that they give us in the top, where they tell us that this, which would be the X is 1.5 meters, and then this is 1.5 meters as well. So we can use that and the Pythagorean theorem to solve for the distance of DC. So I did here. The distance came out to be 2.12 meters. So now we have to solve for the force. So the force of DC in the x direction would be equal to the force of DC times 1.5 over 2.12 meters. And then in the y, it would be the same. The force of DC y is equal to the force of DC times 1.5 over 2.121. So now that we have all the components, we can now sum up our forces and our moments and solve for all of our unknowns. Okay, so the next thing we want to do is sum up our forces in the x and in the y and set them as our A components as equal to the rest of the force. So sum of the forces in the x would be equal to AX plus the force from DC, x set equal to 0. We want to set AX equal to FDC. Same over here in the y. AY will be equal to the 4 kilonewton force subtracted from the force of DC y. We do this because when we're going to sum up all of our moments about point A, it will make our AX and AY components go to 0, which will allow us to solve for this force, which we can later come and plug back in to these other two equations to solve for those components. So the sum of the moments out point A will set equal to 0. It's going to be AX times its moment arm, which is 0, AY times its moment arm, 0, the 4 kilonewton force times the 3 meters of its, then the FDC times its 1.5 meters of its moment arm. Set all of that equal to 0. That'll give us negative 12 kilonewtons per meter plus 1.5, FDC equals 0. So 1.5 FDC equals 12 kilonewtons per meter. So the force from D to C is equal to 8 kilonewtons. So we can then go and plug that back into these two equations down here, which will give us a final AX is equal to negative 5.66 kilonewtons and an AY of negative 1.66 kilonewtons. And that's this whole question. Pretty simple, straightforward, kind of like what we did in drill today. So thanks. That's it.